Warning. This video segment contains information on sensitive topics. Anyone younger than the ages of 18 should not watch this material. The conspiracies, theories, and information presented in this video are based on our own beliefs and evidence gathered from credible sources. What you hear may or may not be the truth, so we ask for you to discern the information and encourage to do your own research on the subjects talked about. Again, this is a warning and watch at your own risk. You have been warned.
4 cheeks,
1 couch.
And 4 cheeks, 1 couch, take 1.
It's this like closest star system to us.
the universe?
Yeah, like in the galaxy, like in the universe.
Yeah, so like for example, the Milky Way is our universe.
It's like 2.4 million light years away. No, 2.4 light years away, not million.
You know a cool thing?
Just like
Speaking of light years, right?
that's probably way off, by the way.
Well, probably, but that's part of the internet, right?
I'm gonna get fact checked for the next year and a half.
I really hope you do. I'm just saying, Matthew out there, I'm saying, if you know the fact, check him on that. I love it. I want it actually.
Alpha.
I don't care if you
Centauri.
Google it just to find out. Copy and paste it and just put it in there so he's back.
Except Google's not gonna tell you.
It might. You don't know. You don't know Google.
I had
Why are you telling what to do?
my nose was running one time.
Yeah.
I Googled it.
Mm-hmm.
So I was dying.
Oh, did you go on WebMD?
Yeah, that's where you always go.
No, see, you didn't use Google. You used WebMD, dog. That's a different thing.
Anyway.
Okay, so it's about light years, right? Galaxy, another galaxy. Yeah.
I'm a big space guy, so.
Okay, so you know a little bit about time relativity theory?
Yeah, that I probably already know it. So let's hear it.
Oh, you already know it then, right? Is that what you said?
I said I probably already know it. Let's hear it though.
Okay, so there's actually I'm giving like a weird example, right? Mind-boggling.
Mm.
So there's literally a theory within a theory that you can have like an identical twin. So imagine if we had an exact copy.
That's exactly where you're going.
Right? No, you don't.
I do.
Okay, then tell me the rest.
If you had
An
two
exact
identical copies
yes,
of a twin, and you
Yes.
stuck one on a spaceship,
yeah,
and you sent them into space at the speed of light,
yeah,
and you had the other one stay on Earth.
yeah.
The one on Earth I forget the years, like the exact years, but they would age by so much. And if it was like 5 years on the spaceship, it was like 60 years on Earth.
And yet, what happens though?
You don't age you only age on the spaceship by 5 years. When on Earth, you're aging
Yeah,
by.
so when you come back, how old would that person be like from the spaceship be?
Okay, if they were both 20 years old and you sent one in the spaceship for 5 years,
Mm-hmm.
so 2.5 years there, 2.5 years back.
Yeah.
Okay, he would be 25.
Okay.
While the guy that's still on the Earth, still on the planet,
Mm-hmm.
is now like 60.
That's literally it. That's the exact thing. So, I mean, I don't know why you didn't know what the name of it is called.
Name of what?
The theory.
I don't know what the name of the theory.
I literally just told you.
Time relativity.
Yeah.
I think that's like an example of theory.
No,
I think
that is the theory.
I think the theory is.
Oh my gosh.
I think the theory is that.
You know how I learned it?
Oh.
In a physics class, dog.
You ever watched Interstellar?
What? Only once.
You probably hate that movie, don't you?
Actually, no. Okay, so actually, okay. How do you know? The ending is what I didn't like the ending. You know how
The ending is pretty trippy.
You know how he's stuck in like the
the bookshelf.
Yeah, and then like he's the start of it at the same time. It's like it was a weird Inception movie.
Yeah.
Like a spin.
A lot of people get those two movies.
That's what I'm saying. Like why?
Yeah.
Why make them so close when they're not close?
Okay, but that is the time relativity theory. Because you know when they're on the planet,
How is that time relativity though?
let me get to it. You know the planet that they're on.
Yeah.
The gravity is affecting the time. Okay. Gravity affects time and space.
How?
It bends time and space.
Does it?
It does.
Are you sure?
Yes,
Are you sure?
I'm positive.
Okay.
You know how many documentaries I've watched on that?
Okay, then tell me about it. Then I'm
telling you
right now.
I was telling you right now.
I'll do it for Matthew, dog. Tell me.
The planet itself that they're on, I forget the name of the planet,
Yeah.
but they're on the planet. And
So are you just talking about in the movie?
and every
it
one
bends time.
1.25 second or minute, every 1.25 minute that passes on that planet, like 7 years pass on Earth.
Mm-hmm.
That's why when they get back, his daughter's like
Yeah.
super old.
Yeah. But I'm saying, like, so is it only in the movie that it bends time?
No, like that's
Not in real life?
the theory. Like it actually does it.
Are you sure, though?
Yes.
Okay, can you tell me a real life example on how it does it?
Okay. Everything that you're seeing, right? Not yours,
Mhm.
but everything that we are seeing and from telescopes and everything else
Mm-hmm.
off in space happened millions of years ago.
Yeah, but how is that affected by gravity?
Because when light is going through space,
Yeah.
it's
Keep
being
going.
bent by gravity.
How?
So the
how
theory
can light
is
itself be bent?
because it's just lightweight.
But it's not affected by gravity.
Yes, it is.
How?
Because
Okay,
it
so
slows it or speeds it up. I made that up in my head right now.
I was like, "There's no way. There's no way because
Well, why not?
it's a constant. The speed of light is constant.
No, it's not.
Yeah, it is.
No, it's not. You can literally,
Yeah, it is.
you can literally break the
MC
speed of
squared,
light,
dog. MC squared.
but you can literally break the speed of light.
Yeah, you can break it, but it's constant. I mean, like the measurement for it is
No,
constant. Yes,
because you can stick
is.
it in a glass of water and it's going to slow it down.
Oh my gosh.
You can speed up and slow down
It's all
the speed of
relative,
light.
dog. That's the whole purpose of the time relativity thing. It's relative theory.
No.
Yes, it is. It's like, for example, when you're in a car and you're traveling at 80 miles an hour, right? When you're in that car and you sometimes look out the window, you can literally see things like you're going like 20 miles an hour. You're like, man, why am I going this slow? But when you're outside the car, it looks so much faster. You know why? Because you're standing still versus moving. Right? It's moving, you're standing still. So your relative is nothing, right? But when you're in the car, right? Everything's moving past you at the same rate. Why are you rubbing your head, dog? Why are you rubbing your head?
If you take a giant Olympic-sized swimming pool, if you take a giant
Okay.
Olympic-sized
Okay,
swimming
a pool. Cool.
okay, fill it full of water,
Okay, what about it?
and you take a laser,
Yeah.
a super high powerful laser,
Yeah.
and you're standing on like where you're not facing the water, and you just shine it. That's the speed of light.
So wait.
Like you're shining, you
if
just shine a
I'm
laser at the
putting it
wall.
At the
Forget
wall?
the pool right now. Forget the
Okay,
pool.
so
You
the-
just shine a laser at the wall.
Okay.
Okay. However
Okay.
far you want it to be.
Okay, well,
100 feet.
okay, so it's 100 feet to the next wall. So if I'm just
Alright.
pointing it,
Yeah.
is it how powerful is this laser?
I mean, it's the speed of light, so it's like,
Okay, so it's constant.
yeah, that's the constant.
Do I
and
need
every
to, do I need to
test.
find the speed of light constant so we can have an actual
Yeah.
number? Okay. Because there's an actual like
Yeah, it's like
equation for this.
It's like 3.141519267.
I think you're close.
Oh wait, that's pi.
Okay, so it's
I was close.
right.
We'll say 300 million miles per second. We'll round up by a couple hundred thousand.
It's 186,000 miles per second.
186,000 miles per second.
Yeah.
Okay, so is that meters per second?
Yes.
Okay, so 180,000 miles per second. All right.
Okay.
And you shine that laser toward a wall that's 100 feet away. It's going to reach that wall super quick. Can we agree?
Yeah.
If you put
Like
a
nanoseconds.
swimming pool in between you and that wall and you shine the laser through the water will slow it down.
Okay, so wait. Good question. Is the whole room now the swimming pool?
Exactly.
No.
Yes.
Because like I'm wondering because that wall would be the wall that I'm pointing to because I can't really.
You're
technically-
drowning underwater and
Going
the
upward?
only
Am I going upward then at that point? If I'm under the water and the wall's up here, right? Because if I'm pointing
the
at the
wall
pool
is straight in front of you.
yeah, okay, but is it the pool wall or
Back
the wall?
to back to the constant. There is a wall that's 100 feet out there in front of you, and you
Okay.
shine a laser.
Yeah.
At it. One of those pointer lasers that you get at the fair every year.
Yeah.
That you lose 3 days later.
I suppose it's a powerful laser, not the.
It's got really
Dollar
strong
Tree.
batteries in it.
It's
And
like,
you shine that laser at that wall. All right.
yeah.
And then all of a sudden, like a magical fairy appeared.
What is this?
And then there's a pool in front of you now, full of water. That's 100
Is
feet
it
long.
lukewarm water or is it like room temperature?
Room temperature for
Okay,
the
so
test.
can you tell me real quick what room temperature is?
Room temperature, there could be multiple room temperatures.
But tell me, what's the temperature of this room
70
temperature
degrees
water?
Fahrenheit.
That's not room temperature, Doug.
What's
Nice room temperature is like 68 for me.
69 degrees Fahrenheit.
Okay,
we'll take the average.
Yeah, right between. Okay, so it's 69 degree water.
69 degree
Right?
water. All right,
Yeah.
That's pretty gull water when you're
Yeah,
in it.
it's
So
pretty-
I guess
it's
it's
pretty nice.
technically not room.
Pretty nice.
Yeah. Okay. And you shine a laser through that water.
Through the water to the other side of the pool wall.
Yes, that's 100
So
feet
not
away.
the actual wall.
Exactly the side of the pool. That's 100 feet away though.
Okay. So now that actual wall got moved another like what?
Yes. Now there's
50
another wall
feet?
that's in front of it. You took 2 steps back to make up for the distance of that new wall sliding in there.
Okay. So the new wall is 100 feet away.
And you shine a laser.
Yeah, I'm underwater.
Yes.
Going.
Yes. You shine a laser.
Surprising that the laser works underwater, but
Waterproof
yes.
laser.
It's like laminated or something. Like a waterproof. So I'm shining it, right?
Yeah.
You know what's gonna happen?
The laser will reach the wall slower than what
No.
it would have.
No,
Yes.
I won't be able to perceive that because we can't determine nanoseconds, dog, with our eyes.
But we have a super high powered slow motion camera at the end of that
And you
underwater
don't-
because it's
and
high
you-
tech.
Okay, so you know what? For one, what I'm thinking about, whatever, I was trying to look at the laser. I'm kind of surprised that I'm just keeping my eyes open the entire time, trying to measure for
This is like
the speed of light.
super. No, you got goggles on.
Okay. Okay, is it like one of the swimmer goggles or like the big?
No, like the
ones?
big one, like the
like,
big
you know,
one.
like almost like scuba gear,
Yeah,
like scuba Steve.
You literally have scuba gear on.
Okay, so now I'm not drowning. I'm actually breathing.
Medium sized flippers though.
I
Not
can't have
the big
small.
ones. No,
I want small
they're gonna
ones.
cut the circulation off of.
I want the ones. I want the ones with your shoes that
back
have
to
toes
the-
in it.
Back to the topic. Aiden.
Okay, fine. Keep waiting.
The water
Mm-hmm.
will slow down.
It won't.
I actually don't know if it will,
I'm
but
pretty sure it
I
doesn't.
was on that train and I'd already dug the hole, so I had to full send it.
I'm pretty sure it doesn't.
I would like to know
'Cause
that.
I'm just okay. Well, we're gonna ask, our fans, or whatever, whatever you guys want to call yourselves. It doesn't matter.
Pause the video.
Maybe
Comment
people
who is
that
correct.
think we're just dumb. It's fine too. Like, you don't even have to think that we're even both correct. You might think that we're both wrong. Please tell us why we're wrong, because I like to learn new things. Even if it's like that, I love chasing squirrels. Cool, love that, right? But I'm just saying. Oh my god. Okay, what am I looking up again? Let me
If
just tell me.
water affects light,
Okay.
because I want the public to know that I was
Well,
correct.
I'll do because the second search is gravity, by the way, and you know what the answer is? By an actual university. Wait, scratch that. National Radio Astronomy Observatory. Right, that's big words. Right, and you know what Jeff Mangum said to it?
What?
He said gravity doesn't affect speed of light.
It does.
Boom.
It does.
Boom.
You're gonna believe him over Stephen Hawking?
I mean, he said it 2 years ago before you said it today. So I'm just saying.
who do you believe more? Some guy you've
And
never met in your entire
knows
life?
Einstein, dog.
How do you know he knows Einstein?
He says he's.
I know Einstein.
No, you don't.
Can you prove it wrong?
Yeah. What's his middle name?
Albert.
That's his first,
Little do people know
That's his first name.
that his
dog.
actual name was Geralt.
Do you live around the river?
Yeah.
Oh, okay, that's fair. But okay, so like for example, he actually used an example of this, right? He says, if light travels from a distant star to Earth and passes by a black hole, the path of the light will get bent as if it passes by
Exactly.
the black hole, which will lengthen its travel time, right? The actual speed, though, is unchanged. So the path is changed.
Yeah, not the
Right?
speed.
But again, that's a black hole, so it's totally different because nothing escapes a black hole.
But I'm still correct.
No, because
Yes.
because that's not technically the idea of our gravity.
I did not say
You originally started with the idea of gravity affected the speed of.
it does.
It doesn't.
What is
slow
a black
down.
hole?
It doesn't.
What is a black hole?
it doesn't slow it down. It just makes the travel time longer.
Exactly. It affects
No.
it.
I
said
my gosh.
I said that gravity bends time and space. Okay?
It doesn't bend the time.
Yes, it does.
No, not time and space. It just bends things. Right?
Time and space.
Okay, okay. Just hear me out.
I'm hearing you.
Are you sure?
I'm hearing you.
I don't think those headphones are working, dog. Because it says a black hole, right? You know what a black hole does?
Yes.
What does it do?
Sucks things in.
Like what?
Everything.
Like what though?
Everything. Light, everything.
Okay.
Nothing can escape it. That's why it's called a black hole.
Okay. So what happens if it's a normal thing? Like for example, if a planet
They
had
just get
gravity.
sucked apart.
No, I'm saying if a planet had gravity, is that compared to a black hole?
No.
Okay, is anything compared to a black hole in space?
So you mean like size? You mean like
no, just
gravity? The gravity of it?
Just the magnitude.
No.
Okay, so you would say the black hole is a different category.
No,
Right?
it's the same category.
No, is it a different category in the phenomena out there?
You're still comparing gravity between objects.
Yeah, but a planet will never have the same effective gravity pull as a black hole.
Okay, but it's still gravity, so it's still in the same category.
But we're talking about a huge difference.
Okay.
Right? Because, like, for example, if we had, I think it's like what, like 9.8 like meters per second,
Meters per second squared.
right? From Earth. But it's like a lot less on like the moon.
That's
the moon is
maximum
real.
velocity.
Is that what it is?
Yeah, I don't know what you're thinking of. 9.8 seconds or meters per second is like the max velo when something's like falling toward Earth.
Are you sure?
Yeah,
Are you sure?
yeah.
Then what is gravity on Earth?
I guess 9.8 meters per second squared.
So it's the same thing. I was right.
I don't know. You were saying there's something about the moon?
No, it's a different thing. Like it's a different measurement. So like for example, it is right. The moon's surface is 1/6.
I'm
powerful.
confused on what you were. Okay, I was confused on what you were
So the
saying.
moon's gravity is
Yeah.
1.6 meters per second, right? But ours here on Earth is 9.8.
9.8.
So you see, there's a bigger difference.
Yeah.
So like for example, the path of
Is there
travel,
a black hole on that list?
right? No, I can look it up.
Look it up. I want to know.
Okay.
I want to know what the.
Okay.
You probably can't even test that kind of thing.
I mean, we probably didn't. They just recently actually found out the complete existence of black holes.
Yeah.
You know how I know that?
Oh.
Physics, the same class that taught me about the time relativity thing. So it's actually kind of cool.
Wait, you learned it recently, or they discovered it recently?
No. We actually watched like the breaking news thing.
You're talking about the picture of it when Stephen Hawking
No.
took the picture. Yes, you are.
No, there was
Black holes have been around for a while.
Gosh. No, I'm talking about like the full effects of a black hole. So, like for example, they
How
actually
it
had
sends waves throughout the galaxy whenever they collide together.
no. Okay, so there was actually a like manufactured kind of like place. I don't know what you would consider like a study observatory. Boom, that's the actual word I was looking for. In I think like Utah or something like that. It was like some like northern
There's
state.
nothing. Utah.
Exactly. I guess it was like probably like in like Nebraska where everything's flat. You can see for like 800 years, across this, the whole state by just coming outside, right? Kind of one of those like one of those states. It was in the United States, of course, and they observed the effect, right, that black holes have, right? So you know how they actually did. It's kind of funny because think about it now. They had high powered lasers that were like
the one
like
we used in our swimming
precise
pool.
and no, like it's like it's like so precise that it's like measured down to like in like a microscope kind of thing. So you'll be able to tell that it's off because all ran by a computer, right? And then they were studying when like a black hole would get close enough to have an effect, like how close it would have to. And eventually it worked. Like it knocked as like the Earth rotated. I think is what it's like. It was in the thing because it's been like 4 or 5 years since I've been in high school with it. But like they have 4 segments. So like the main actual observatory was in the middle, and then they had 4 underground like tunnels built. Right, they had things above it, of course, but like the lasers were like perfectly unaffected by anything else. Like that's how accurate they were. But each one was affected because of a black hole.
You do know that there is a black hole at the center of every galaxy, right?
No, it's not.
Yes, sir.
No, it's not.
Yes, there is.
No, can you tell me why?
It's literally what makes it up. Everything rotates around the black hole.
What's this? Still just trying to find out. Okay.
So everything's affected by a black hole.
I mean, yeah, because again, a black hole is something different. Like if there was a big
But
enough
it's the
black
same
hole
thing.
that could suck up the whole universe, it could probably do that. Think about it, dog. Just saying.
Okay, but I think the people's perception of a black hole is different than what it actually is.
What's
A black hole doesn't pull things into it.
What else does it do then? I was waiting for you to finish it, but you never said anything.
I was waiting for you to be like, ooh.
No, I was just waiting, dog.
A black hole, things like once you cross the horizon, that's when you can't escape. Otherwise, we'd be sucked into a black hole right now.
I mean, not really.
Yeah. There's one at the center of our galaxy.
Where?
The center of the galaxy.
Where is it? Where's the center of it, dog? Can we find out the exact center?
God. He's good.
What?
Okay,
What?
we on Earth
Mm-hmm.
are the center of the known galaxy. Or
Is it-
universe,
is it
not
because
galaxy,
you're-
universe.
Is it because of your privilege or something?
No, it's because we can only see so far out there.
Again, your
Because of how
privilege.
far the light has
Your
traveled.
privilege, right?
Huh?
Check your privilege.
Every day we see farther and farther because the light finally reaches us from those places.
Yeah, so like the sun, right, isn't technically there. Is that what you're saying?
What do you mean?
The sun's technically not there, but
I mean,
it's there.
technically not. Because when we're seeing it, when we finally see the light from the sun, it's already in another spot.
It's like midnight there on the sun by the time we see the light, right? Is that what it works?
So you know when Elon Musk puts somebody on Mars here in a few years?
Oh, you mean like the Tesla car in space, dog?
Exactly. When
By
they,
the way.
when
I mean, Elon, if you want to give me a Tesla, that'd be cool too.
if he wants to come on the pod, talk about some SpaceX
Oh,
stuff,
dude.
I'm all for it.
Yeah, exactly. Go on.
Anyway, I know, not even that. All the Mars rovers missions that have been happening.
Oh yeah, also ripped to the Mars rover.
Yeah,
It's old news, but it's fine.
when it's landed and everything, and like they're like controlling it,
Mm-hmm.
it takes so long for that
The input, yeah.
for the input to be
Yeah.
received.
Because of how far the distance is.
Yes, exactly. So that same concept is like the edge of the known universe. Okay,
Okay.
and that's why. What? Why are you
I'm just
making-
waiting.
Why are you making that face? That's what I'm saying.
waiting. And it's gonna be like, because the laser pointer is so that like the speed of light is affected because gravity pulls the edge of the universe.
You still yet to prove me wrong on that.
What about what?
That gravity affects light.
It doesn't affect it.
Yes, it does.
No, it just changes the path.
Oh, so it affects it.
No, you were saying like it slows
Gravity?
it.
No.
Yeah.
No.
Yes.
No.
Yes.
No.
Like the speed of how fast the thing is moving isn't changed. It's the time it takes to go to one place. But that how fast it's actually going. So like for example,
I don't know what my exact words were, but I want to know.
Okay, but
When I
we're
stated
gonna-
this argument.
we'll test something, right? I'm gonna record you, right, running, right, and it'll be like in front of like one of those speed signs, right? And then I'm gonna record you in slow motion,
Yeah.
but you're gonna be running as fast as you can,
Yeah.
right? Me showing you running in slow motion, does that change your speed?
That's not at all what we're talking about.
But I'm telling you, does it change your speed?
No,
dog?
but that has
But
nothing to
does
do
that
with what we're
change-
talking about.
Does that change your speed?
Yes.
How?
Or it doesn't change the speed. Sorry,
Okay,
no,
so
no.
see, you just proved my point. Thank you, Doug.
No, what-
I'm just
that
saying,
has nothing
you guys
to
heard-
do with
you guys-
what
you
we
guys
were
heard it
talking
here
about.
first. That if I recorded him running at a certain speed, right, and put it in slow motion, that he, you know,
That has nothing to do with what
how
we were
does it
talking
not?
about. How does it?
Your path took a little longer to get to a certain point, didn't it?
Because you slowed a video of me running down.
It's like my gravitational pull, right?
No.
Like literally, think about it though. So, like for example, right? You you're in a shower, right? You're in the shower.
Let me.
I don't know if you actually take showers.
No. Let me break it down for you.
You're going to do the
I'm going to interrupt you, and I'm going to break you down.
Okay.
Here, okay.
Okay.
When you look at a picture, when you Google like space pictures, okay.
Okay. You can do it right now.
Yeah. Google a picture of a black hole. It's not going to show you an actual picture. It's going to show you
probably like the weird black hole with the orange.
Don't look at that one. Look at like one of the older ones. Yeah, because it's got to be right. Or just look up even planets. Okay.
Which one? You want this one?
That one right there. See how everything's distorted around it?
Yeah.
That is because the light is being bent. Okay?
Yeah.
That light has taken longer to get to us than what it would have been if that black hole wasn't there.
Because it's not heading in our direction, dog.
What?
So for example, if we were, they can't really see, but we'll say we're on the side, like the left side of the hole, right? Because the hole's here. We're on this side, right? The light coming here, right?
Mm-hmm.
That from here to the edge of that black hole is going to remain constant, right?
Yeah.
The speed that it's going to continue traveling at is that, but the path that it has to go around is what's
Takes
different.
Longer, exactly.
Right? But the speed doesn't change. The path does.
I don't remember ever saying the speed changed, but
you literally did. You said the speed of light changes based off of the gravitational pull.
Okay,
right.
Well, I will accept the fact that I don't remember saying that. It's like that. What my original statement was is that gravity affects space and time.
Yeah, and I'm telling you, it doesn't, because the idea of speed of light is constant.
But not one time did I say speed. I'm saying space and time.
Space and time.
Time.
Right? So, because we were talking about time relativity, right?
Yes. Okay, so my statement is that gravity affects time. So how long it takes, not the speed of it. Yeah. I'm saying it takes a different amount of time.
Okay, but we went on a complete side tangent.
Because you don't understand what I'm saying.
Because you're saying there's a time of things, right?
Yes.
Okay, but I was saying, for example, we wouldn't know if the time was changed.
But we do know if the time is changed.
How?
Because we can test that.
Can we?
Yeah.
In which way?
If you take a laser, back to my laser pointer.
Oh my, the Dollar Tree laser from the carnival.
Take the Dollar Tree laser.
Okay.
And you point it at the moon.
Okay.
Okay. You can flick your wrist. Wait, don't ever point a laser at the moon, by the way.
Yeah, because
you can get in some serious trouble.
It makes it moldy.
No, you could get some serious trouble for that.
How?
You've never heard people get in trouble for that?
No.
That's
I've seen it
that's a federal law.
You get in trouble for pointing it at helicopters.
Yeah, that's why you're not supposed to point at the moon, or up in the air.
Because the astronaut's gonna get blind or something.
Yeah.
Oh, I thought that was Hollywood.
Sure. I don't know. The government points cameras at us all day long. I can't point
remember the pigeons, dog?
I can't point a single laser at
I'm
the
just
moon.
saying, if somebody ever has a baby pigeon, I want you to show me it. I don't want to see a picture. I want to see an actual baby pigeon.
And
to prove that they're not cameras. Go on, though. We're pointing a laser at the moon that you're not supposed to do.
Wrist.
Okay, so I'm going.
The distance from the top of the dot, where you started, to where you ended, is not important to this argument.
Was it the same distance or a different distance?
No, I used to know that argument, but about halfway through, I forgot how the argument ends.
So, does that mean I'm right then, dog?
No.
You already forgot your argument.
I forgot that argument. I have many more arguments.
Okay, well, then we'll just continue. Go on then. Give me one more.
I'm still confused on what we're even arguing about now.
Okay. So
restart this whole conversation.
Okay, no. I'm gonna go to we're gonna
time relativity.
Yeah.
Gravity affects time and space. That is my original argument, and that is still my argument.
So you're trying to say that it's affecting time and space, and I'm gonna ask you, how does it actually? No, I'm not saying black hole.
Okay, no. I'm saying
how does gravity itself affect time and space?
Okay, the space part's different. Okay, but I got an argument for that.
Okay, so we're gonna talk about gravity.
Yeah, affecting. Okay.
Yes. Okay.
Have you ever taken a blanket and you pull it tight?
Yeah.
Okay. And imagine you put a basketball in the middle of that blanket.
Okay.
Okay, it kind of like sinks in, you know?
Well, if it's really tight, then no.
Loosen up a little bit.
Okay. So we have a semi-loose thing that's like cradling the basketball. Okay.
The basketball is like kind of like drooping down.
Yeah.
Okay. And then you take like a smaller ball, like a baseball.
Okay.
Right? And you like flick it out there, right? And it's gonna like rotate around the basketball until it gets sucked in to the basketball. Okay. You staying with me? Hang on. You staying with me?
It's going until it goes around it.
Then you take a golf, and even smaller. Okay, you do that. And it's gonna do the same thing. Okay. Go with me.
Okay, so now we have the basketball, right?
A baseball.
And
And a golf ball.
then a golf ball.
And we're gonna throw a tennis ball in there too.
Is a tennis ball after the golf ball?
Yeah.
Okay.
Yeah.
Okay.
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 You know how they all like eventually like.
No, because the golf ball gets smothered by the tennis ball, but it's fine. Keep going though. Keep going.
The way the basketball bends the blanket is the same way a planet and its gravity bends space.
Okay, so I'm gonna ask you 2 questions. Okay, so the magnetic field, right, for one, and polar axis. Did you ever think about that?
Yeah.
Because, like, for example, our planets.
Whoa, did you know, for example, every like 100 billion years or something like that, Earth like has flipped upside down?
Yeah. You know why?
I don't know exactly why.
Ice Age.
Why would the Ice Age cause a flip?
Don't worry about it. Al Gore, dog.
Yeah.
No, okay. So that's a topic for some other time.
But is that
right?
the coolest thing though?
Yeah. Well, I knew that, right?
I don't have any years.
But like going back, the only thing that example fails at is that they don't have their own axis.
What?
Right. So like planets, like for example Earth.
Yeah.
Right. So even though it's going around the sun, right? It has its own rotation, keeping it in place, like a gyroscope.
But then it's also got the
like a gyroscope.
Yeah, but there's also more rotations to that.
But I'm saying like it's not directly getting pulled in completely because it has its own spin that's causing its own gravity, like gravitational. That it's not going to be affected by that.
The spin isn't what causes gravity. Everything has gravity.
So we were talking about your example. Is the basketball's the center?
Yeah, but you said the
like
spin
sun,
caused the gravity.
But like the sun,
yeah,
right? And then here's this, right? And it's gonna pull everything in around it, right? The sun, technically, yeah, it does pull because it's in the center. But at that point, it's not gonna touch though.
You ever been?
Because it's going like this, right? And I think it's like centripetal force.
Yeah,
that's
like what I was about to say.
Right?
Yeah.
So
the
it's
centripetal
doing this,
force keeps it on the outside.
So it's just doing this, right? And eventually, if it's like here, and again, it just kind of floats, and it's just constantly getting pulled in. What's happening? Do you hear that? I'm just saying, some gang stuff's going on outside or something like that, right? But like it's going like this, and then like all of a sudden, this starts spinning though, right? So we have 2 different kind of spins. It's gonna keep it from going.
But then you have more spins on top of it.
What's the other spin, dog?
Galaxy spin.
Okay, but how is that affecting the center of the galaxy?
Center of what? How's it affect?
So we're talking about the center, right?
The center, the very center is the black hole.
If
that
we're
we were
spinning the
about.
blanket.
No, forget that.
Okay,
forget
so
that.
we're not using that example anymore that you brought up.
No,
so
because you're
importantly.
changing everything about
No,
that.
I'm talking about.
Not everything in the galaxy spin.
But
when's the last time a comet has been spinning?
But we were talking about the ideas because I know the reason why you put those balls in there, like, is because the fact of they're representing the planet.
No, they could represent anything.
Okay, so then what were they supposed to be representing?
Astronauts.
They all like just like an individual astronauts.
Yeah.
So is that like one really big astronaut in the middle, and then there's a mid astronaut? Okay, well,
forget every example I've used in this one episode.
Okay. You know, I'll just say, I guess again because of like the last episode, right? I'll give you a shadow of a doubt.
Yeah.
Is that all you wanted from
I'll
me?
take it.
You just wanted a doubt kind of thing? Like, yeah, it's I can see
I
it.
said it at the beginning.
I can see that it can influence the path, right? But I still think the time is not changing because relative to us. Oh, so
My original statement in this episode, or this whatever we're calling this,
yeah, segment. Absolutely, I don't know.
gravity affects time and space,
Okay,
not speed. I never once said speed. I'm not saying it does, or I'm saying it doesn't.
I didn't bring that up though. I
But you had made this whole segment
earlier
about
because we talked
speed.
about the speed of light. But I'm talking about now, right? Going back to the original topic, I'm going. Yes, I can see it possible, right? That it influences it, but I'm saying like the time that's quote unquote changed isn't directly changed. You know what I mean? Because like for example,
I'll agree.
Because you know, like we were talking about the relative theory, right?
Yeah.
So if you see something slightly change because time, doesn't mean everything else sees it differently because of time. It might be slightly different. It might be quick. It might be not even like it can be so quick that you don't even realize it. Like speed of light. See what I did there? Right? If the speed of light is constant, right? It will always see that it's constant. If it's a person. Right? If you can perceive things, right? But like we would see it like it's like that's just there.
Yeah.
Like what? Right? But if like a black hole brings it there, we will still not be able to notice because how small our eyes are and how quick our brains can't really comprehend things, right? Because we're not robots for one, unless you're a pigeon. But or like Mark Zuckerberg, but it's fine. But you know what I'm saying? Like, you would not be able to know that changed. Like if we turn that light off to that, you can't see the different, like the distance, like as quick as possible.
But I don't remember ever saying that I could.
Well, we were just talking about time.
Oh, okay.
You see what I'm saying?
Yeah.
Like it's just all relative.
Yeah.
Right? So like if you were moving, I guess, or if you're relative to that gravitational pull, right? Or gravity, then you would know the pull. I guess you would say. You would see how it changes things, right?
Yeah.
But if you're not relative to it, then you're never gonna. That's why we don't feel the Earth moving, because we're not relative to the actual rotation.
Yeah.
Right? Again, going back to like the whole gyroscope thing.
Well, even your car example.
Exactly. Like it's just nothing. It's all relative, right? So like for example, here's an interesting topic. I always think about this like almost every other month for some reason. It really does randomly just pop in my head. Pangea, right?
Mm-hmm.
I think it exists. You know why?
Yeah, let me
I feel like you really don't care.
No.
It'd be fine.
I have my own opinions on it.
Okay. So it's not the whole puzzle piece thing, right? Mine is because the actual species, they're on the south, for fans of a certain show, of my childhood show, right? Drake and Josh, South America or America, right? As normal people would say it.
You know what's sad is there's gonna be nobody that gets that reference.
Probably not, but it's fine.
Yeah.
But they on like the East Coast, the East Coast, they found like remains of like a fossilized like species kind of thing, right? And those same remains, like not the exact same animal, of course, but like the family of it. So like for example, if it was like, we'll say a king snow crab, why doesn't it? I don't know, but like if that was there, like on like South America, it was found on the west coast of Africa, like the same, same like
group or family or whatever they call it of the species. Yeah.
Like and those are two different climates.
So it might not be that same snow crab, but it's like
it might be like his cousin.
Yeah.
Right. You know what I'm saying? Like it's crazy because like those are two different things, right? Because like I wouldn't think that like something that's in like, for example, the rainforest, because South America, right? I can't stop thinking about it now. Has like rainforest, right? Like it has tropical things, but like Africa, what does it have? Desert. like sandworms. I don't know if they exist, but
The Alaskan bullworm.
yeah, like there's no telling, right? But for them to be there, like that shows that something had to happen there. Like I don't know if there was another, like there could have been a whole other continent that we didn't know. Like for example, like Atlantis, right? Could have been inside there. You tired, dog?
Yeah. Because you're so boring.
Oh, okay.
No.
No, just go ahead.
No. I completely agree, though. On a real note, why is it when you're driving down the road, so you're eating like popcorn? All right.
Okay. We're eating popcorn.
I'm going back to the
road.
topic you were just talking about before you got on Pangea.
Okay. We're just bringing it full circle.
I was gonna say, but I want to interrupt you.
Okay, go ahead.
So you're driving down the road and you're eating popcorn,
What kind of popcorn?
buttery popcorn that you brought from the movie theater.
So like real butter. Like, I mean like
Yeah.
butter. Okay.
And you drop a pea. Why does it go in your mouth?
Wait.
You're riding in a car. Okay.
For one, where did I drop it?
No, you're beating out of the bucket, all right? Straight out the bucket. And then you're trying to get it to your mouth.
Wait. Which hand am I using? Because I don't want to touch my steering wheel.
You're right hand.
Okay.
Wait, no, you're riding. I'm driving.
Okay, so I'm in the passenger seat, just full on shoveling in my.
Yeah. And then you just drop it. You know how it just
It
goes
falls
straight down.
back in the bucket.
Why doesn't when you drop it does it not land on your chest or something? Because you're still moving forward.
It is relative.
I don't think you know what that word means.
Because it's okay. So for example, even though we're the car is moving, we're not moving.
But we are moving.
No, because for example, right? The Earth is moving, but we're not moving on this couch.
If we're in the car is moving.
Okay, so if we had somebody,
We're doing 110 miles an hour down the highway.
okay, again, do we need to get some friends down here and push our couch forward as we sit here, and then I want you to drop your phone and see if it hits you in the face?
Exactly. That's what I'm saying. Why doesn't it?
Because we're not moving. We are not moving. The couch is moving.
But we're on the couch, so we are moving.
Oh no! Oh my gosh!
If you were in a car, you're telling me if you're in a car and you left to California and drove all the way to New York, not
Yes.
one time did you move?
No, I physically did not. Well, I mean, I move my hand. I'm driving. And my foot.
You're riding, I'm driving.
Okay, so if I'm riding, right? If I'm not moving, it's like if I was weird, again, like a robot, right? And I'm just sitting there. I'll just move. So I'm not moving, right?
Why does the popcorn not land?
Okay, so the only thing I am doing is reaching in the bowl, and grabbing popcorn and eating it, right? That's the only move I'm about, right? So we're saying I'm riding in the car, you're driving, you might be listening to music, I don't know, right? But I'm saying I'm just eating. That's it. This is the only movement I have. Not both hands, just one hand now, right? And see if I go right here, and we'll say I drop it.
It's going straight back into the bucket.
It's going down. You know why?
That's what I'm trying to get out of you.
Because I'm not moving.
You are. If you're a rocket ship and you're headed for Mars.
Hey Brandon, I want you to move your arm, right? Like this.
Back to what I was saying before you rudely interrupted me.
Look, it went straight down.
But you're not moving.
I threw it.
But you're not moving.
Okay, yeah, but I'm not moving in the car. I just told you I'm not moving.
If you're in a rocket ship.
Okay, so we're changing
for Mars.
Okay, I'm moving a rocket ship and to Mars, yeah.
And they just happen to let some random guy on there with a bucket of popcorn. You got all these astronauts with you. And they're sitting behind you. Because when you're in a rocket ship, you sit down and facing upwards.
Yeah.
Okay?
Yeah.
And you just drop a piece.
Yeah.
Going straight to your mouth. All right? You know what I'm saying?
Because we're going vertical.
Yeah, okay. But hear me out. Say we're going straight.
Okay, so we're on
Say
we're on a rocket ship horizontally.
Yes.
Okay.
Because something messed up and you fell down on the ground and now you're just going straight.
Okay, so we're not moving yet?
No, you're moving.
Okay, so we're how about this? We're on an airplane.
Yeah, that's even better.
Okay, so we're on an airplane.
But it's a super fast airplane, like a rocket ship.
So it's a rocket ship airplane. So we're going this way, right? Again, not counting in the idea of momentum because it's a whole different topic.
It's the same category.
No,
it's the same category.
No, it's not.
This is.
No, it's not, Adam Sandler. Like, it's not, because that's a whole different, like, factor.
No.
Yes, it is.
No.
Because that's the same thing as, like, centripetal force. Because, like, for example, when you turn the car, right, or the rocket ship, right, depending on how hard you're going, it's going to force you to go in that way. Because you know why? That's an outside force pushing you.
I don't think you know what you're talking about.
Oh, my. It's Newton's third law, dog.
Ooh, the law of thermodynamics. I'm glad
I'm just saying, I know my stuff.
you do know it's not the law of thermodynamics.
I don't even know
What's his first law?
I don't even know it.
You don't know what Newton's first law is?
I just know it's something. I know one of them is, you know,
That matter cannot be created or destroyed.
that's not a law of motions?
No, that's Newton's first law.
Is it his first law?
Yes.
Are you sure?
Yes.
Are you sure?
Yes.
Okay. I'll just look it up. Because I don't even know that.
Well, maybe you should.
What?
Maybe you should.
It's not, no. First law of motion, dog. That's the only thing he has. Maybe you should learn.
What law am I thinking of?
That is a law, though. That matter cannot be destroyed or created, kind of thing.
That
Right?
it can only be transferred or whatever. What law is that?
It's a conservation of mass.
I knew it was something.
So you were trying to roast me about not knowing Newton's 3 laws, because I know there was 3 laws of motion, right? One has like opposite
Potential and kinetic
reaction,
energy.
like, you know, like so
Everything
like a force
has
has to match.
every force has an opposite like
yeah.
equal reaction
or something.
Yeah.
Yeah. And like, you know, we know our stuff. Don't worry about it, guys. We know our
It's
stuff.
like 2:00 in the morning. I am tired. I have no idea what we're talking about.
But you know what I'm saying though? Like, I mean, okay, so that force is acting on it. So like, for example, if we for some reason have this huge high powered fan in the car, when I drop that popcorn, it's gonna push the popcorn here because that's a force pushing it. But if me doing this, the only force that I'm pushing it down, because you know what that is? Gravity.
Okay. Well, then why? Okay, say you're back on the rocket ship, headed towards space or Mars, and all of a sudden the rocket ship just stops. Just wham! Just hit a brick wall, but not like a literal brick wall.
So somebody
You're
brake
dead.
checked. Somebody brake checked. Okay. What
But
about
like the quickest brake check ever. Like you don't even scoot, you just come to immediate halt.
Okay. What about it?
You don't die then, right?
Well, it depends. Or am I wearing my seatbelt?
Yeah.
Okay. Is it one? So, how hard are we going? And do I have?
You're
any
a rocket ship headed to Mars.
Okay. Do I have any protection?
You have a seatbelt.
Oh, thank.
A car seatbelt, not even a rocket ship seatbelt.
Okay. They really put me on a budget. Okay, so
It's like a random guy on a rocket ship. They don't have a budget.
okay, so we're doing that, right? And it stops just for some reason. Like, I mean, like abruptly. I mean, like we're going probably like
Like a rope was tied to the end of it, and as soon as the rope got tight, it just stopped.
Dude, that rope would break for one on a rocket ship.
It's a metaphor.
Okay.
Or a simile, I don't remember.
Oh my gosh. Okay. Well, for one, just because it's the idea again about a force acting on another force, right?
The rope is no longer there. You just stop all of a sudden.
Again, going with what I said, if it's a force acting on another force, that has to go somewhere.
Nope.
Yes, it does. It's in the law of motion.
Okay.
We just said it. It always has an opposite reaction.
That doesn't explain why the popcorn don't fall to my face.
Oh my god.
I just want a world that I can live in where I'm driving down the road and I can just let go of it and it goes right into my mouth.
Okay, so then, like, for example, if you're laying down in bed, right, and you have your phone over, right,
you drop it on your forehead.
and you drop it, why doesn't it go up?
It's gravity.
Okay, but exactly. If you're holding it sideways, so if you were standing up right now, or well, actually, do it right now, pick your phone up.
Okay.
Right? And drop it. Drop it. Drop it.
Yeah.
Why didn't it hit your face?
Because my face is up here.
Now pick your phone back up.
But we're not in a car moving.
No.
We're not in a car doing 110 down the highway.
Pick your phone back up. Okay. Are you ready for this? Don't hold on to it tightly. Let go. Move your thumb a little bit.
No, my God.
I'm just showing you something. Move your thumb real quick, right? Like hold it, like not real tight, not real tight.
It's not tight at all.
Okay, you ready? Why'd your phone move? Why'd your phone move that way? Why'd your phone move that way?
Did you hit it?
Okay, I'm a force pushing it this way, right?
Yeah.
Okay, you see what I'm saying here?
No.
Oh my gosh.
I definitely do. I do.
Yeah. So you see. So if we're in a car, so like next time we're in a car, right? We're gonna buy you some popcorn.
I don't like popcorn though.
Oh my God. Hey, what do you like?
I mean,
Like Cheez-Its.
pizza aren't bad.
Okay, so we're gonna get you some box of Cheez-Its.
But I like the original, not the.
Oh my gosh, so needy. But okay,
like
so we're getting you the
three cheese or
original
whatever.
weird stuff, but we're getting you original. You know, they're probably stale, but it's fine. You know, and you're gonna go eat one, and I'm gonna smack it out of your hand. Straight.
That's still not my argument.
Okay, then I'm gonna have you drop one. Because we know that you're gonna drop it because you're gonna try to eat it. You're gonna try to eat it, and you know you're just you're just gonna let go.
Oh yeah.
I mean, how many times do you let go of things?
I mean, I hold grudges, so not very much.
Okay. No, but okay, for real, we'll just have you drop it.
Yeah.
And I want to see if it hits.
I've tried it before. I know it won't hit.
Okay, so then why did you ask me?
I wanted to know why it didn't.
Because you're not moving. Because I'm gonna. Okay, so what we're gonna do?
That's a totally different argument.
Okay, so then I'll have you do it right now. Right? Are you ready? So
If you were in a car, you are moving.
Okay, but what I'm saying here, right, is that you're not actually moving. You're not moving now,
So you're
right?
teleporting.
Oh my God, the car is moving. You're not moving.
But you're in the car.
The car is moving. You're not moving. You're physically not moving, but the car is moving, carrying you.
If you have a box of leftovers from the restaurant you ate at the night before,
yes,
and you stick that box in the microwave,
yes,
you're not warming up the food inside of it. You're only warming up the to-go box.
yes,
That's what you're saying.
yes.
Okay.
Because you know why? You know how microwaves actually work in that point? Because there's vapors, right? Like there's water vapors up in that box, dog. And that microwave's heating that box, causing those water vapors to become steam. And that steam is heating the food. Boom. Done.
If you're in a car,
Okay, so we have
you are moving.
No, the car is moving. You're not moving.
You are.
The car. You're moving now. Like you did. I'm moving you now.
I want you to go get that box of food, stick it in the microwave, and warm up the box without warming up the food.
Okay. That's every food ever in a bowl.
No.
Have you ever tried warming up like macaroni and cheese, Doug? And
Yeah.
it never gets warm
Yeah, it does.
on the outside. But
But you don't have a lid on it.
Deep down.
But you don't have a lid on it.
Deep down.
What are you warming up in your microwave?
Okay, but back to what I was saying. You're not moving. You're literally not moving though.
All right. I'll
So
agree
next
to
time
disagree.
you're if you
I
start
will
moving,
agree to disagree.
move in the car.
Agree to disagree.
Okay, fine.
How are we doing on time?
I don't even know because Mike didn't tell us the time, so I think we're like
This has been a talked episode because you were wrong about everything.
he's gonna have a lot of editing to do, so it's gonna be great. Good job, Mike. I don't know if he's gonna have this in the video, but
I have yawned so many times.
I know because you're so
tired.
Thanks for checking us out. This has been Josh and Brandon at 4 Cheeks, 1 Couch, right? I'm glad that you're enjoying our dumb show that we just do every week on Thursday. I hope you enjoyed our conversation that we had about like time and how space and stuff is affected with gravity.
And how you were wrong about every argument.
You can just shut up. It's fine. You know, you just gonna eat your popcorn. But so again, tell us if we were actually wrong and which way we were wrong. Right? Fact check Brandon all the time because he needs it. Right? Unlike me, as we know, definitely. But again, subscribe, like this video, keep coming back. Even check out our main show. It's gonna be coming out, of course, on every Monday. But again, thanks for watching, I guess.
Yeah, don't forget to comment other topics you want to hear us talk about.
Oh yeah, that's true. If you have any suggestions,
all our stuff would be linked in the description below.
Of course, my Instagram's going first. After the main one.
I pay everybody here. So.
Do you? Cause I'm pretty sure.
Mine to go first.
Are you sure?
If you look at it right now, mine's on top. It's actually right here in my hand.
Don't do that.
Can you do that?
Don't do that. Put mine up there, actually.